This tutorial shows you how to calculate the minimum required sample size for the Mann-Whitney-Wilcoxon test with G-power. When we start G-power, we get this overview by default. We now need to select the Mann-Whitney-Wilcoxon test first. Selected via tests means two independent groups, Wilcoxon, non-parametric. Because you want to calculate a minimum sample size in advance, you have to select a priori. The first input parameter you have to specify is whether you are conducting a one-tailed or two-tailed Mann-Whitney-Wilcoxon test. Two-tailed means you cannot tell in advance which group has the larger median. If you do, however, select one-tailed. The second input parameter is the assumed parent distribution. Min ARE or asymptotic relative efficiency is the most conservative assumption and is a good default. The third input parameter is the effect size Cohen's d. The G-power manual states that the conventions by Cohen that are applicable for the t-test should be used for the Mann-Whitney-Wilcoxon test as well. They are 0.2, 0.5 and 0.8 for small, medium and large effect sizes. If you have research field specific thresholds, however, please use those instead. Finally, if you have a preliminary study or a comparative study where an effect size exists, you should rather use that. Transformations in advance from R to D might be necessary though. The fourth input parameter is the alpha error probability, which is the probability of committing a type 1 error. In short, this is the probability of wrongly rejecting the null hypothesis. 5% is the typical convention, 1% is a bit more restrictive. A value above 5% should be avoided. The fifth input parameter is power. Power equals 1 minus the beta error probability. In short, this means falsely retaining the null hypothesis. 95% power is typical, meaning you have a 5% type 2 error probability. In some research field, a power of 0.8 is used here. This means you automatically accept a type 2 error of up to 20%. If you have power lower than 0.95, this calls for a reasonable justification. The sixth and final input parameter is the allocation ratio. This is the ratio of the number of observations for the two groups you expect to have or aim to have. Equal group sizes would result in an allocation ratio of 1. Finally, hit calculate to see the minimum number of observations needed to detect the presumed statistical effect with the predefined type 1 error probability and power. As a rule of thumb, a smaller effect size and a larger power require more observations than the other way around.